Hi viewers, welcome to Lama Solution. Today we are going to see about a hybrid solar PV wind diesel generator system in MATLAB. This is a simulation model we created for a hybrid PV wind diesel generator system. So the system consists of main grid. Main grid rating is around 154 megawatt and voltage rating is 34.5 kilovolt. And it going to be connected to the transformer. This is step down transformer. It going to be step down the voltage from 34.5 kilovolt to 400 kilovolt, and it going to be connected to the hybrid system. This is a hybrid system. The hybrid system is going to be connected in the 400 volt line. The hybrid system consists of PV panel system or PV panel array with the corresponding inverter control, and here we have a wind generator along with the wind turbine. Here we are using PMSG wind generator, and here we have a diesel generator, and also the hybrid system or micro system having critical load, two critical loads and one non-critical loads. Here you can see that this is a rating of PV system. Here we are using 41 kilowatt PV system, and then inverter voltage is 400, grid frequency is 50. Once go inside, you can see the configuration. That means PV array is going to be connected to the DC link, and then it's going to be connected to the grid inverter having inverter control along with the MPPT. So it will supply the around 41 kilowatts power. Here you can see the PMSG wind turbine system. Rated voltage is 400, and then rated power is 1.5 megawatt. Rated frequency is 50 hertz, and DC capacitor voltage is 1050 volt. Number of pole pair is 48. When go inside, you can see that system. This is PMSG, and then machine side converter, grid side converter, and this is known as wind turbine model. The wind turbine model is the wind speed and then rotor speed of the PMSG, and then it will be provide the torque command. And this is having two control, grid side control and rotor side control. Here we are using speed regulator and pitch control. So based upon speed regulator and pitch control, it will be generate the torque command. Torque command going to be given to rotor side converter, rotor side control. Inside you can see that this is a rotor side control. So here we are using feed forward decoupling control concept, and then here also grid side also we are using DQ control, feed forwarded decoupling control by DQ control method, and both control will be generate the control signal for this side converter and the grid side converter, and how to transfer the power from the wind generator to grid side. And next here you can see that this is a diesel generator. The diesel generator is rated at 430 kilowatts. The rated voltage is 400 and the rated frequency is 50 hertz. When you click inside, you can see the synchronous machine having this diesel engine governor and the excitation system. This diesel engine governor and excitation system used for the main. This engine governor used to control the prime mover, that main input, mechanical input of the synchronous machine, and then this excitation system used for control the field of this synchronous machine to maintain a terminal voltage at constant. And then here we have a critical load 1, load rating is 400 kilowatts, and then here critical load 2 is rating is 80 kilowatts, and then this is non-critical load, its rating is 500 kilowatts. So once you simulate this one, you will see here right in this scope, it is used for measuring the grid power, solar power, wind power and diesel power. Here you can see the grid power is negative, that means grid receiving the power from the hybrid system PV wind diesel. So this is solar power is around 40.5 kilowatts, and then here you can see the wind power is around 1.5 megawatt, and here you can see that this is diesel power. Diesel is supplying power around 25 kilowatts, and also you can see the waveform for different buses. For example, you consider this wind turbine bus, this one. Here you can measure the wind turbine grid side bus. That can be, you can see here, this is a wind bus voltage and current, and then here you can see that in this point you can see that BV side bus voltage and current. That can be seen here. Here you can see the BV bus voltage and current, and then here you can see that this is a diesel generator bus voltage and current, and then here is a critical load 1 voltage and current, and then this is non-critical load voltage and current, and this is critical load 2 voltage and current, and then this is a grid side voltage and current. This is voltage and current, and here you can see that the power of critical load and non-critical load in terms of kilowatts. This is working of hybrid solar PV wind and diesel generator system along with the grid integration. Thanks for watching our videos. Kindly subscribe to channel and also hit bell icon for notification about upcoming videos. Thank you so much. Bye bye.